There is a habit of thought, common enough to escape notice, of treating the limits of imagination as the limits of reality. We encounter a formalism that resists visualization and reach, almost reflexively, for the word abstract, as though abstraction were a property of the mathematics itself rather than a property of our capacity to render it. This conflation has a specific consequence in mathematics that I want to examine. What 3 Blue 1 Brown does particularly well is provide geometric intuitions for mathematical constructs that, in their algebraic form, appear arbitrary or opaque. The geometry behind Euler's identity, the meaning of a rotation in the complex plane, the visual logic embedded in a determinant. Watching these explanations, the immediate instinct is that something has been revealed, that the formalism was always a shadow of a shape, and the shape has now been shown. That instinct is right, and it implies something that tends to go unacknowledged. If mathematics is the formalism of reality, and reality is, as argued in dimensional inherency, inherently geometric regardless of dimensionality, then every mathematical structure has a geometric grounding. The ones 3 Blue 1 Brown can show us are the ones where our perceptual tools happen to reach. The rest are not exceptions to this logic. They are the same logic, operating past the edge of what we can picture. The rotation of a complex number through the unit circle is geometric. The tensor, expressing how a quantity transforms under a change of coordinates, is geometric. Euler's identity, that collapsed statement of 5 fundamental constants, is not a coincidence of notation. It is a geometric truth in algebraic dress. We happen to have the perceptual range to glimpse it from a certain angle when someone draws it out carefully. But for other structures, higher dimensional symmetry groups, the geometry of Hilbert space, the topology of fiber bundles, we are essentially colorblind. The geometry is there, the apparatus to see it is not. The word abstract has been misapplied. It describes the perceiver's relationship to the structure, not the structure itself. A formalism is not abstract in the way a painting might be abstract, generously departing from representational form. It is only abstract to us, in the same way that ultraviolet is only invisible to us. This is not a minor semantic complaint. It has consequences. When we call a formalism abstract, we begin, gradually, to suspect that it is in some sense less real, more arbitrary, more constructed, less anchored to anything outside the symbol system. This is exactly the mistake. The distinction matters beyond mathematics, and it is not being made for the first time here. The threads have been followed in prior posts. That perception is a constructed interface rather than a direct read of reality, living with filters, perception, color, and belief, that the universe is always exact, and the discrepancy lives entirely in how we register and interpret it, the discrepancy between the ideal and the lived reality, that even our most formal frameworks carry the fingerprints of the beings who built them, the human in the equation. What mathematics adds to this picture is specificity. Unlike the physical world, a mathematical formalism either predicts correctly or it does not. There is no ambiguity to hide in. So when a formalism predicts correctly while remaining unvisualizable, the argument is settled. The geometric reality it maps to exists, independently of our ability to render it. Quantum mechanics is the sharpest example in recorded history of this settlement being forced. The formalism is not intuitive. The wave function has no home in classical geometric imagination. The Hilbert space in which quantum states live is not something a human mind can picture in the way it can picture a rotation or a surface. When the theory was taking shape, the resistance from working physicists was not primarily technical. The objection was not this predicts incorrectly, but this cannot be how reality is structured, because the structure, being unvisualizable, felt more like a convenient mathematical device than a description of anything real. This is precisely the conflation I am describing, the failure of pictorial imagination read as evidence of ontological absence. The theory holds. Every precision test has confirmed it. Whatever geometry the formalism maps to, and there is geometry there, in the structure of Hilbert space, in the topology of the state space, in the geometry of quantum information, it is real. Our inability to render it visually is a fact about human perceptual range. It is not a fact about the formalism. 3 Blue 1 Brown at his best is doing something pedagogically important and philosophically suggestive. He is showing that the shapes were always there behind the symbols, that the algebra is not arbitrary, that it has geometric bones. The further implication, the one this series has been building toward, is the extension of that claim beyond what can be shown. The shapes are always there, even when no one can draw them, even when we lack the dimensional vocabulary to name them, even when the most careful illustration in the world would be missing most of the structure. The formalism points somewhere. That somewhere is real. Whether we can see it is a separate question. One about us, not about where the mathematics points.